Good morning, everyone. I'm Larry Kandel. I've been at Lincoln for a very long time. Most of my day job is in building satellites. But when COVID-19 came along, a lot of people at Lincoln, because it was such an emergency, we got involved with all different aspects of trying to understand what was going on and what we could do about it. What I'm going to talk about today is just a simple job. I'm going to try to make all of you into junior epidemiologists by the end of this little lecture. And so just shout it out to me on the chat. How many epidemiologists are you kids right now? Is anyone actually an epidemiologist among you guys? Anyone? That's good because oh, we have one epidemiologist, so maybe I'll let him give the presentation. Daniel, you want to step in and talk about it? Yeah, I didn't think there were too many. And so my job today is to take this giant word. I think there's 14 letters or 13 letters in epidemiologist and 7 syllables. It's a pretty big word that a lot of people have been throwing around for the last 8 months. And so my job today is to tell you what it's all about. And we're actually going to use a couple of web tools to actually do some experiments in real time. And I think it should be fun for you guys. Before I get started, I was just going to switch gears for 1 second. I'm going to talk about this. Does anyone know what this is? I don't see a lot of people. So this is called a digital caliper, and it's a really cool thing. It's especially for a nerd like me. I love measuring things. So if I want to measure like the width of this quarter, I can just stick it in here. You can see how I have a little quarter. I stick it in, and you can read the display, and it shows you that the quarter is what, 0.931 inches, right? And then I can measure the width of it, which is a lot narrower. And then you can see it tells me that as well. And I'm having a little trouble reading it, but hopefully you guys can see it. And so this can measure the width of anything. If I push it all the way back down to 0, it measures 0. I'm going to take a piece of paper and I'm going to measure the width of it. And so even though a piece of paper is really thin, when I put it in there, you can see that it actually still can measure the width of that piece of paper. And let's see what I'm reading here. It says it's about 0.0025 inches in width. That's pretty thin. What if I took that piece of paper and I folded it in half? I'm going to take it and fold it in half now. Does anyone have any guesses as to how thick this piece of paper is going to be now that I folded it in half? I see some people coming through on the chat that it's like, yeah, if it was 0.0025, and now I'm going to show you that, in fact, it's reading 0.005. I'm going to fold it again. Actually, I'm going to fold it 2 more times. And so what do you guys expect it to be if I fold it 2 more times? It was at 0.005, and now it's going to I folded it 2 more times. I'm going to stick it back into my little digital caliper. There we go. Push it nice and tight along there. And what am I getting? I'm getting about 0.0022, right? 0.23. And so if I keep folding that over and over again, each time I do another fold, it's doubling the width of that piece of paper. And so that is, kind of an interesting thing that you might be asking yourself. You're like, Larry, I thought you said you were going to talk to me about how to become a junior epidemiologist, and all you're doing is measuring the thickness of a piece of paper. Does anyone actually know why I'm asking you these questions, and why am I measuring the thickness of a piece of paper like that? Why would I? What does that have to do with anything that we're talking about today? Well, maybe it has nothing to do with it. Maybe I made a mistake and I'm giving the wrong lecture. No, actually, I think there's something interesting going on there. I'm going to switch my screen now. I'm going to show you. So at the top of this chart, what we saw was that the paper thickness was 0.00275 inches. And then each time we folded it 1 more time, the number of layers doubled. And the number of inches doubled as well. And so we did it a few times, but if we did it a bunch more times, like 4, 5, 6, by the time we did it 10 times, that would be like 2 inches of paper. If we did it 10 more times after that, up to 20 times, we'd have 2,800 inches of paper, or 240 feet, right? And by the time we did it like 25 times or 28 times, we'd actually be best off measuring it in miles, right? So the width of that paper, just by folding it a few times, is growing very, very quickly. And each time it gets folded, it doubles. And I got news for you, that has a lot to do with epidemiology. And that's what I was gonna hope to talk to you about today. So my job is to make you a junior epidemiologist. Let me, I'm gonna switch my share. So what you're seeing here is that, that this is the number of cases that were reported every single day for the entire epidemic in Massachusetts. And you can see that, you know, like it started off very small. This was before the epidemic started. And then it went up high, and then it started falling off, and then it started zooming back up again. And the question I have for you is that you can see that there's 4 different labels, for A, B, C, and D. I'm kind of interested in which one you think is the most alarming of those 4. And so what I was gonna do is launch a little poll, and I'm kind of interested. So, you know, do you think it's A, way back in March? Do you think that the scariest part, or the most alarming part, was in May? Do you think it was in November or December? I'm starting to get the results. A few more people want to vote. I'll give you a few more questions. I mean, a few more seconds, and looks like almost everyone has voted at this point. Okay, I'm going to end the polling. So it looks like the biggest one was December, and so what you're seeing here is that I think a lot of people are probably picking D because of the fact that let me see. So most of the people were picking D over here, and I think that the reason is because this is when we were having the most cases per day. Now I actually think that the most alarming part is actually right back here at A. And the reason is that if we were to look all the way back here, what you'd see is that it was behaving almost exactly like the digital calipers that I was seeing, where every 5 days, the number of cases that we had were doubling. And it turns out that even though these look very alarming, it never was growing nearly as fast as what was happening in those initial 5 days. And the reason is that in the early days of the epidemic, we first of all didn't have a lot of information about what was going on, and people were showing up at hospitals, and every day there were more and more people showing up. But it wasn't just that there were more and more. It's like every few days the number of people was doubling, and we had no idea when it was going to come to a stop. As time has gone by, we have a much better understanding of the types of things that we can do, and what it is that are the dynamics of this epidemic. And so when it turns out we want to know what an epidemiologist is, there's 2 pieces to what an epidemiologist is. First of all, when I talk about epidemiologists, I always break it down into 2 parts, right? So it's an epidemic plus an ologist. And ologists are things like a geologist or a radiologist or dermatologist, like different experts is an ologist. And then this is someone who's an expert in epidemics. And the 2 things that an epidemiologist wants to do is, first of all, they want to try to measure how epidemics grow. That has a lot to do with like what I was showing you with my calipers. And then they want to know what to do about it. And that has a lot to do with some of the things that Alan was talking about in the first part of the talk, is how do you use all of these things to make it so that, things don't grow. And when I said that I thought that the first phase of it was the most alarming, even though there were very few deaths and cases in the early days, the rate of the cases were growing in a much more alarming way. And in the same exact way that things were going to get way too big for my calipers because they were going to be measured in miles, we were worried that this epidemic was going to get way too big for our hospitals, and it was going to all happen in a matter of days. And for the rest of the epidemic, we figured out how to use all of these different tricks to slow things down and make it so that we could accommodate the people as they were getting sick and as the epidemic was growing, and to make the epidemic grow much more slowly. So, so now we're going to switch gears, and what we're going to try again is I'm going to send a link to all of you, and we're going to actually simulate an epidemic on the web. And so I'm going to try that right now. I think what I'm going to do is I'm going to stick it in the chat for you. Did you all get a link in the chat? If you did, click on it. It should open your browser. It may show up on your phone. And if you're using it on your phone, it probably is best to turn it into the wide mode. Don't look at it in the vertical way, look at it in the wide mode. But if you get that link, you should be able to just enter your name in. And I can see that some of you guys are doing that now. So right now I have 17, 20 people, 22, there's about 75 people on the call. So, so as you enter that in, I'll give you a few seconds to do it. What's going to happen here, and I'll explain it to you, as you start logging into it, is you're going to all be kind of simulated people in an experiment where we spread an epidemic. And the way that we're going to spread it is that, that when I start the simulation, I'm going to infect one of you, and then you're going to get a button that when you push that button, you'll infect 2 other people. And sometimes you'll infect 2 other people. What's going to happen a little bit later is that as some of those people are already been infected and they can't get the disease again, even though you've infected 2 people, you may not actually infect 2 other people. So right now we have 45 people. We can run this a couple of times, but so if I were you, I would keep looking at your own screen. You don't have to look at what I'm doing. I'm going to start the epidemic now. And so there's a person, Andrew R., got infected. And now Andrew sees something. And so Andrew, I think, just infected some other people. So Wes and Katie just got infected. And what you're seeing on the plots is that, now there's 3 people with infections. It looks like Wes and Katie and Noah, you can infect some other people too, because you probably have some buttons on your screen right now. And if you do that, other people are going to get infected, and 2 other people are going to get infected. So Wes and Katie and Noah, looks like they both clicked on it. And now all of a sudden, what you're going to see is that as time goes by, that more and more people are getting infected. And now the epidemic is starting to grow a little bit faster and faster. And you can see that with this plot here, that very quickly, all of a sudden, even though we have many, many people on the call, that the disease is spreading very quickly. And so it looks like Allison and Alan, so you can see that that more and more people are getting sick. And you can see that at first it was only a couple of people, and then it grew to, in one of the days, we had 16 people, and then it started falling off. The other thing that you can see is that it's falling off. And the reason that it's falling off is very important. And that's that even though you're infecting 2 other people, some of you are seeing on your display that some of the people that you're infected had already had it. And that's why the epidemic actually fades away eventually. So the other thing that you see is this pie chart, and this shows you that there are some people that actually didn't get it. So many of the people have already had it. They're called removed. There's only one person left that's infected, that's Alan. He could infect someone else if he pushes his button. And now there's no one else who was infected. The 2 people that he infected had already had it. I'm going to try it again. This time, let's try to do it as quickly as possible, and we'll see how quickly it goes. Okay, go ahead, Adam. Come on, push that button. It's going fast. Oh my goodness. Wow, we got 23 people infected on the first day. You guys are going so fast. And then it's already falling off. So all of that stuff got lumped into the first day because you guys did it so quickly. But you can see that even though we did it quickly, it's still, not everyone got infected in the end. And the reason is because we're just like running out of people to infect. We could try it one more time. I'm going to reset it again. This time, let's try to do it a little more slowly. Okay, Ariana, just wait a second. Okay, go ahead. Let's infect someone. Okay, the Tambo twins and Andrew R. All right, Alan, Alice. Andrew R., let's see you infect someone. So you guys are slowing it down. Cool. All right, how about Daphne, and good job. So you can see that that what you're doing is by slowing down the thing, we can actually change the shape of this epidemic. All right, I think let's stop with that. What I'm going to do is I'm going to actually send you another link in the chat now, and it's going to be another game that we're going to play. And so, if you're ready for that, I'm putting it in the chat for you right now. Actually, before you don't click on that link yet, let me give you a little bit of background about what you're going to see. So if you come back and look at the screen that I'm sharing, you're going to see the game that. Can everyone see that?
Yes.
Great. Okay, so what you're seeing is there's three different parts to this. One of them is I've taken all of the little dots of all you people and I put them on here. And instead of you guys doing the clicking now, it just happens the way that it happens in real life, which is that there's a bunch of people, they're moving around. And as they move around, they bump into each other and they come in contact with each other. And it's that contact that actually spreads the virus. And so what you're seeing here is that in the beginning, I take two people at random, I give them the virus, and then every time they bump into someone, they spread it to someone different. And that's what you're seeing in this plot here, is that all of these people that are turning red are actually getting infected. And at first, everyone gets infected very quickly, and this curve grows quickly. But then as more and more people become infected and they recover, you can see that they start disappearing. And then even though they're just moving around just as fast, they stop bumping into as many people, just like we were seeing before, how the curve starts bending over and falling off. So this looks like how it is in the beginning of the epidemic, where everyone is moving around, they're very active. And the first thing that we decided to do is we said, hey, let's not have people move around so much. And then that's what this interaction rate is over here. So if you see this interaction rate, if I lower that down and say, hey, I want everyone to slow down and not interact so much, you can see that that actually lowers the R naught, which is how quickly the virus is spreading, because I'm not letting people run around and bump into each other as much. And then what that does is all of a sudden, that's going to flatten the curve, just like we were trying to do in the beginning of the epidemic. And so let me run it again with this lower rate, and you can see that we start off with two people. They were before the testing, so they were not documented people. But you can see that it's still spreading pretty quickly. Well, another thing we can do is we can wear masks. And what masks do is they say, even though you bounce into someone else, you may not actually spread it to them because the mask is actually lowering the chance that you would spread the virus. And so by changing that probability of infecting, that's the equivalent of putting masks on all these little people. And so we'll reset it again. And what you'll see here is that now you'll see that we're moving a lot slower. We're wearing masks that are making it so that we have less infections, and that's great. Well, another thing that we can do is that rather than, if we knew that these people were actually sick when we do tests on them, we may not want them running around in our little city here. And so the way that you can do that is if you click on some of these people, you can see that they move off to the side and they're put into quarantine. And so if you can click on them fast enough, you can make the epidemic go away because if you prevent them from clicking on anyone else, then you can actually prevent the epidemic from spreading. And so that's that's the equivalent of putting people in quarantine, where they can't move around, they can't interact with other people, uh, and it's a very effective way of slowing down the virus. Uh, there is one problem, which is that right now what you're seeing is every time someone gets infected, they turn red. And this is like the perfect thing. It would be like when someone gets sick that we know exactly what's happening. Unfortunately, for COVID, a lot of people have fairly mild symptoms. Actually, it's fortunate that they do. But that means that it's harder to detect that people have it. And that's this testing bar over here. And what this testing bar is it says, well, not everybody gets tested. Only a small fraction of people, and it could be like 20% of people get tested. And what this means is that even though you're bumping into other people and they're getting infected, it doesn't always turn the bar red. So now if I run it, what you're going to see is that there's these initial 2 people that I infected. Some of the people are being documented, other people are not being documented. And what that means is that there's people floating around in here that are spreading the disease, but we don't actually know because we don't have tests for them. So even when I get rid of all these people, it looks like all of the sick people are gone. They're not really all gone. And you can see that the virus is continuing to spread, because like if you look at this curve on each day, it's still spreading around, and it just keeps popping back up again. And that's exactly what we see when we play around. So the link that I sent is exactly this game. And it's something that you can all just click on, play with, and let me know your thoughts. But it's a great way of getting some understanding of how the virus spreads, and then all the different things that we can do about it. So with that, I think I'm going to stop. And if you have any questions, I'm happy to answer them.
Thank you, Larry. Again, we appreciate you doing your presentation today. So for everybody else on the call, I do want to remind you that this video is being recorded, and it will be posted on our external website at ll.mit.edu/outreach. And also some of the questions you guys asked that we didn't get to, we will send those out to our panelists, and they'll have them answered, and we will also post that underneath the video of this show, so you can get your answers. We'll try and do that as soon as possible, but please give us about a week to get that done. So without any further ado, I want to thank you all for showing up on your Saturday and being very active on chat. I love it, love it, love it, and you know I love it. So thank you. So our next show will probably be around March time, and